Welcome back. In this section, we are starting a new topic. We're learning about tissues, and then we're going to take them all the way to organ systems. So let's get started learning about tissues in general, and then moving on to our first type of tissues, connective tissue. So, as you recall, we had a hierarchy where we went from atoms to molecules and cells. And now we're going to move on to two or more cells moving together for a common purpose, which takes us to tissues. And when we're talking about tissues, we have four types of tissue. So we're not talking puffs and Kleenex, those types of tissues. We're talking about the four types of tissues that are found in your body. And so if somebody says, name that type of tissue, there's only four possible answers: connective tissue, muscle tissue, nervous tissue, or epithelial tissue, also known as epithelium. Okay. Now, when these tissues work together, they're for a common purpose, they're going to form organs. And as you know, when two or more organs work together for a common purpose, they're going to form the organ systems. So remember, four types of tissue. So let's delve into our first type of tissue we're going to learn about, and that is connective tissue. So if you had to guess what connective tissue does just from its name, you would guess it connects stuff. And you would be right. Connective tissue of the four types is the most abundant type of tissue in your body. It's very widespread. Think of it as the ubiquitous peanut packing material. Here's what it looks like, kind of like the inside of a lady's purse. A little bit of this and a little bit of that. Very whatever. And when you look at it, there's some things you can identify. You can see cells, right? Yes. And then you can see a whole bunch of stuff that's not cells. And the stuff that's not cells is outside the cells. So we say it's extracellular, which just means outside the cells. And because it can look like a lot of different ways, we call it the matrix. So it's called the extracellular matrix, or you can just call it the matrix. Doesn't matter, because it's cells or it's extracellular matrix. Two things make up connective tissue. But when we look a little bit closer at the stuff that's not cells, then we can start to see some other things. We can see some linear structures, like you can see this dark brown linear structure. You can see this bigger blue linear structure. And both of those things are protein fibers. So we know the extracellular matrix, one of the components are protein fibers. And then the other component is all this background brown stuff. And you can see it's got splotches in it. So it's got different chemicals and proteins and different kinds of things in it. And that's called the ground substance. Okay. So connective tissue is made out of two components: cells and extracellular component matrix. And the extracellular matrix is made out of two components: ground substance and protein fibers. All right. And when we look at connective tissue, we say it has a low cell to matrix ratio. And that means there's a lot more matrix than there are cells. The cells are scattered among the matrix. Okay. And there's going to be different types of connective tissue. For this course, we're only going to learn about 6 types of connective tissue, but in reality, there's more than 6, but 6 is plenty for this course. And most of those are going to have blood vessels in that extracellular matrix, and most of those are going to have nerves in that extracellular matrix. So you can assume it has those things unless I tell you it doesn't. And when I tell you it doesn't, then I'll explain the significance of not having it. Okay, so let's kind of like stop and think for a second. Look at like this little jello shot thing. Okay. You've got jello, you got pieces of celery, and you got pieces of banana. So that is connective tissue. Which part is what part of the connective tissue? Can you figure that out? Yeah. So what part would be the cells? What part would be the ground substance? What part would be the protein fibers? What part would be the extracellular matrix? All right. That was pretty simple and straightforward, but it got you thinking about connective tissue. All right. So now let's talk about cells and connective tissue. Because when you look at this picture, you're going, oh my goodness, I don't know any of these cells. Look at all of those names. Do we have to memorize all of those names? I'm going to go, nope, nope, we're not memorizing all of those names right now. I'm going to introduce you to a couple of them, and the rest of them, when we get to them, we will learn about them. So the first thing I'm going to introduce you are to the suffixes that go to some cells. If a cell ends with the suffix blast, what that means is that's an immature cell that's actively producing the substance. It's a builder cell. So if we were to take the prefix osteo, like most people know osteo, like osteoarthritis has to do with bones, okay? And osteoblast would be actively producing the stuff to make bones. So it'd be like building the bone house. Okay. Now, as all of you know, once the house is built, you no longer have to build it, but you got to do a little bit of maintenance, don't you? So you can't just retire. So from that point, we move from a blast to a site. And yes, I know I told you the word site means cell. So these are the mature cells, but it doesn't mean they're at siesta. They have retired. They're less active than the blast, but they still do some active maintenance. And so if you look over here in the picture, you can see a lymphocyte. Then sometimes we have cells that end in the suffix clast. And these are the ones that are going to be breaking things down. They bring in the wrecking ball and they are the destroyers. Okay. So learn those three suffixes. And so let's talk about one cell, the fibroblast. So from looking at it, you know what blast means. It's actively producing. So now you look at the root, fibro. What do you think this cell is actively producing? I bet you might guess fibers, as in those protein fibers that, along with the ground substance, make up the extracellular matrix. And you would be 100% correct. But there's going to be more to the fibroblasts, as we'll see shortly. I also want to talk about the macrophage. So we know that word phage from phagocytosis, which was the eating. So phage still means to eat. So a macrophage, macro means big. So a macrophage is a cell that's a big eater. Okay. So here's an example of a macrophage. And as you can see in this picture, there's another one up here and there's a third one over here. And so macrophages are cells that are part of our lymphatic system, also known as our immune system, and they go around and they're kind of like scavengers and they're looking for debris and things that don't belong there. And when they see them, they're going to eat them. They're going to clean up on aisle 6. Leukocyte, leuko means white. These are your white blood cells. Later on, we'll learn the names of your white blood cells, but for now, we've got white blood cells in our connective tissue. Why? In case you get some bacteria, you cut yourself. They can sit there and they can start an immune response. Okay. Adipocyte. So a cyte is a mature cell. An adipocyte is just the scientific term for a fat cell. It's a cell that has the storage form of lipids. Okay, and there's a lot of adipocytes in in most forms of connective tissue, as well as their specific form of connective tissue that's almost exclusively adipocytes. But as you can see, general types of connective tissue have individual cells that are adipocytes as well. All right. So let's talk about that fabulous fibroblast. Okay. Among all these different cells in the connective tissue, the fibroblast by far is the most common cell. Okay. And it produces all of the connective tissue fibers. So there's three different types of connective tissue fibers we're going to be learning about, and it produces all three of them. Which one it produces depends on the cell signaling it gets at the time. And so that's going to have to do with, remember, all those little things on the plasma membrane that are sticking out, all those little receptors, look, things, chemicals come and they bind to it, and that tells the cell what to make. Okay, through transcription and translation, we are going to take a certain gene and the DNA, and then we are going to be making the correct protein to make the correct fiber that that cell needs. But in addition to making the connective tissue fibers, it also makes most of the ground substance. Okay, so without the fibroblast, without this cell, you would have most of the extracellular matrix. So super important. Okay. So now looking at the ground substance in general, what is this matrix? Well, it fills all the spaces between the cells. It fills that extracellular space. And we have a synonym for extracellular space because technically all the space between cells is extracellular. But I think in a previous video, I talked about when we're talking about tiny little spaces between cells, we call them intercellular spaces. So to tell the difference, if we're talking about big spaces that are extracellular, we use the word interstitial. Okay. So the ground substance fills these interstitial spaces, all these big extracellular spaces. And the ground substance varies in consistency. It goes all the way from a liquid to a solid. And that is going to determine what type of connective tissue we are talking about. It's not the protein fibers, but it has to do with the ground substance. And in the ground substance, all types. Yes, there's waters. Yes, there's salts. Yes, there's multiple types of large molecules. No, we're not really going to go into detail of any of that. Okay, but let's talk about the three types of fibers. Okay, you can see all three on this picture. So take a moment and look to see. Okay. So the thick black ones are real easy to see. Can you see the really thin little light brownish ones? And can you see the really faded thick pink ones? Okay, so those are the three types. So let's talk first about those thick pale pink ones. Those are collagen. And when I say collagen, I want you to think Popeye strength. Okay, collagen is the most abundant. Okay, it's super strong. There's a little bit of flexibility in collagen. It bends, but it doesn't stretch. And collagen makes up 25% of the protein in your body. So there's a lot of it, especially when you think of how much muscle is in your body. And that skeletal muscle is protein, and it's not collagen protein. And yet 25% of your body's protein is collagen, and this collagen is in your connective tissue. Mind blowing. Okay. So you're going, Dr. Powell, I've never seen collagen. I'm going, yes, you have. Have you ever gone to a grocery store and look at meat? Have you ever bought meat and looked at it? Look at your meat packages. Have you ever seen between little meat fibers this white stuff? That's your collagen. If you're poor like I am and you buy the cheaper cuts of meat, where you can't cook it like a steak and just cook it because you'd be chewing for days on end because it's not tender. The kind of meat where you have to cook and you have to braise or you have to make stews out of it and they cook for 3, 4, 5, 6 hours before they get tended. That's because it has lots of collagen fibers in it. And you've got to break down the collagen. All right. That's the first type of fibers. Okay, so remember, fibers and ground substance were making up extracellular matrix. All right. Second type of protein fiber is elastic fiber. So the elastic fibers are these darker black ones. And so if I ask students, what does elastic fibers do? Everybody goes, oh, they stretch. And I'm going, great. So think about the last time you had a pair of underwear and it stretched, and that's all it did. Or a pair of boxers or a pair of running shorts or sweatpants. If they were stretched out, could you wear them? Of course not, because what's the point of elastic? It's not to stretch, it's to stretch and return to its resting length. Okay, so elastic fibers can stretch 150% of its resting length, but the important part is it will return to its resting length. And so we have tons of elastic fiber in our blood vessel walls, so that when a bolus of blood from our heart pumps blood, it's not a little drip, drip, drip like your faucet. It's like, here's a bunch of blood coming all at once. That blood vessel can go whoop, and then it'll return back down. Because you don't want your blood vessels to stay open, like, oh, okay, we're just going to stay open and just in case some blood wants to come by. It's going to collapse back down. The same thing like your skin. We can stretch your skin, but I don't want my skin to be staying up like that. Okay. Your lungs, we take a deep breath, your airways expand, but then we want them to contract when we exhale. So with elastic fibers, that elastin protein not only needs to stretch, but it needs to return to its resting length. All right, and the third type of fiber are these super thin little tiny ones, and these are reticular fibers. They're very thin, they're branched. There's no power in any one by themselves. These are kind of like the little pieces of straw in kindling. When you're making a fire, you put them in there. They fill up all the little spaces. They make a little network to give a little structure to fill spaces. They're going to be really important in some of our organs like our spleen and our liver. And so we'll come back and talk about them at that point. All right. Now, here's the thing about all of these protein fibers. You can't make any of them if you don't need vitamin C. And that was super important way back in the day. And that led to the success of Christopher Columbus because his person, his quartermaster that brought all the foodstuffs on board was well aware of the disease scurvy and the fact that you needed vitamin C for extended voyages. And so he had fruits on board. And that's why they were successful and were able to travel for months on end because those soldiers, not soldiers, those sailors, excuse me, did not develop scurvy, and so they were able to do their duties, and that's why Christopher Columbus named the New World after that quartermaster whose name was Amerigo Vespucci. Okay, so that's it for this section, and I'll see you soon when we return back and we learn about the 6 types of connective tissue. See you shortly.